All right, as we continue our look at working with formulas for functions, the directions are going to remain the same. We're going to find the domain, the y-intercept, and then either the x or t-intercepts, depending on what we're calling our input. Questions 3 and 4 deal with roots. And question 3 is a square root. And as we talk through that one, we're going to just sort of review the rules for all even roots. So if this were a 4th root or a 6th root or a 100th root, all of those count as even roots. And the rules for those are a little bit different from this. Here we're going to be reviewing the rules for odd roots. So, in finding the domain, if I have an even root, like a square root, I can't, in the real number system, take an even root of a negative number. So there are going to be restrictions on my domain. Whatever's under that radical cannot be negative. And if it can't be negative, that means it has to be bigger than or equal to 0. All right. So I can write that down. It's an inclusive inequality because it can equal 0, but it can't be smaller than 0. It can't be negative. So then I would just solve this for x. So I could add the 2x over if I wanted to. And then I would have 4 is greater than or equal to 2x. Divide both sides by 2. 2 is greater than or equal to x, which is equivalent to x being less than or equal to 2. Very often I prefer to have the x on the left. Notice if I preferred to keep x on the left, I could have said negative 2x is greater than or equal to negative 4. So I could have moved the 4 over. Then I would have divided both sides by negative 2. And remember when you're working with inequalities that if you divide by a negative, you reverse the inequality. So it becomes x less than or equal to 2 either way. Now, if I were to graph that on a number line, here's 2. That's included, and so is everything to the left. Not absolutely necessary to graph it, but that gives me a nice visual. I can see there's no left endpoint. So we're going off to negative infinity, but the right endpoint is 2, and that is included. So this is the domain for g of x. Now for odd roots, there are no restrictions. I can take an odd root of a negative number. As an example, if I were to take the cube root of negative 8, that would just be negative 2. Okay. So if there are no restrictions, the domain for any odd roots is just all real numbers in interval notation, everything from negative infinity to infinity. All right, let's find the y-intercepts for these two functions. So just to remind myself, it's the y-intercept, we're on the y-axis, which means the x value is 0. So I'm looking for an ordered pair where the x value is 0, and I'm going to find the y value then by just plugging in 0. So here I want to calculate g of 0. If I like, I can put parentheses around my x. That's just a placeholder for my input. So we're going to have the square root of 4 minus 2 times in that input position, I'm going to put a 0. So that becomes the square root of 4, which is 2. So the y-intercept here is 0, 2. Here, to find the y-intercept, I'm going to do something very similar. I'm going to remind myself that it's a point. It's not just a number, okay? But I want to plug in 0 for x. So we'll have h of 0 is the cube root of 4 minus 2 times 0. So that's the cube root of 4. Now that one doesn't simplify particularly nicely, because if I just run through my integers, 1 cubed is 1, that's too small. 2 cubed is 8, that's too big. So I'll just leave this as the cube root of 4. So my y-intercept is 0 cube root of 4. All right, let's find our x-intercepts. So for the x-intercepts, I want to remind myself that that's going to be where we're on the x-axis, which means our y value will be 0. So I'm just going to take the formula for my function and set it equal to 0, and then solve for x. Now, in order to do that, I want to undo what I'm doing to x. I want to undo the square root, so I'm going to square both sides. So we'll get 4 minus 2x equals 0. So we'll get 4 equals 2x, and x equals 2. So it looks like we're getting the point 2, 0. I do need to be careful. Anytime I solve an equation by raising both sides to an even power, it is necessary for me to check my work. The reason is that even powers eliminate information we have about the signs of things. So let me just give you an example. I'll work it out over here. Okay. If I had something like the square root of x equals -2, that has no solution, no real solution, because principal square roots are not negative. Okay. But if I were to square both sides, I would get x equals 4, and I might think that there's a solution. But if I check, if I plug 4 back in, I'll see no, that does not make the original equation true, because the square root of 4 is defined to be 2, not -2. So I have to check to make sure something like that doesn't happen. Now, in that particular case, you could maybe see, even before you squared both sides, that there was no solutions. It's not always that obvious. So I'm going to just check. It's a necessary step if I've taken both sides of an equation to an even power. When I'm checking, I usually just create a table. I'm going to go back to the original equation, which was root 4 minus 2x on the left side and 0 on the right side. I'm just going to plug in what I think my solution might be and see if it works. So if I plug in 2, this becomes the square root of 4 minus 2. I'm plugging in 2 as my input here. That becomes the square root of 0, which is 0. The right-hand side was 0. That does check. But it is necessary, if you've raised both sides of an equation to an even power, to check it. So we get 2, 0 here. Now for question 4, if I'm finding the x-intercept, again, I know the y value will be 0, and I'm just going to set the formula for the function equal to 0. And then I can cube both sides. So I'm going to get 4 minus 2x equals 0. 4 equals 2x. X equals 2. And I don't have to check. Okay. The reason I have to check for even powers is that with even powers, when you raise things to an even power, you obliterate the information you had about the sign. Okay. If you start with something negative, it becomes positive when you square it or take it to any even power. But if you take something to an odd power, that preserves the sign. So we don't run into the issue that we get a solution to this equation that we have after we cube things that wasn't a solution to the original equation. Okay. So very important differences. With even powers, there are restrictions on the domain. With odd powers, there are not. If you solve an equation by raising both sides to an even power, you've got to check your answer. If you solve an equation by raising both sides to an odd power, you don't have to check your answer. Okay, so questions 3 and 4 both had 2 parts, and I did the first part for both of them. Now this video has been going for a little while, so I'm just going to end the video here, but I'm going to write down what the second parts were. So for question 3, it was k of x equals 2 plus the square root of 5 plus x. And for question 4, it was p of t equals the, I can read, 5th root of t plus 2. So what I want you to do is work out these problems, and then in the next video we'll go over the solutions to those.